Hey peeps, I'm a little bit hyper right now because it's kind of late at night, but yeah. So we'll do the best we can doing this thing. We're going to do 15.4 and 15.5. It's basically just a bunch of theorems. You just have to know them. So we're just going to blitz through them. So first up, chords. Chord product theorem. It says if two chords intersect in a circle, then the products of the lengths of the segments of the chords are equal. I don't have to read this. The important part is you look over here at the little formula example and you see that AE times EB, so this segment times this segment, bam. When you multiply them, you get the same number as if you were to multiply this segment times this segment. So we'll do an example. Here's our example, number 3. The given is that AD is 12. Boom. And you have to find x. So then we do some math and we're like, ED. I wonder what ED is. Well, the whole thing's 12 and this part's 3. So this part's 9. And then you're like, all right. So the formula is I multiply them together. So 3 times 9 is going to be equal to x times 14. So we're going to do that math in our head. We're going to be like 27 equals x times 14. So therefore x equals 27 over 14, whatever number that is, which is that, sure. That's CE. Yep. Cool, moving on. We got a new definition. We're going to do the secant. So the secant, as it says here, is any line that intersects a circle exactly. Oh, hi, wife. Wife is here. She cut her hair for some reason. I don't get it.
He cut my hair.
Secant is
scissors. He attacked me.
A secant is any line that intersects a circle at exactly 2 points. Cool. So here's a secant. Watch this. But lines are infinite, right? So that's a secant. It's a straight infinite line, right? More importantly, we care about secant segments. So a secant segment is any part of a secant line with at least 1 point on the circle. So this could be a secant segment, this could be a secant segment, any segment that has at least one part on the circle. In this case, they're talking about secant segment AE. And then a segment, blah, 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 blah. A segment that lies on the exterior of the circle with 1 point on the circle is called an external secant segment. So they're just talking about BE right here, that section. There's a secant product theorem, which has some text here, blah, blah, blah. But we're just going to read this part that says AE times BE. So again, I'm going to highlight these. So that's the secant segment times the external secant segment, BE. Yep, see, look, I'm using colors.
Ooh.
And that is equal to CE, which is that whole secant segment times DE. I forgot to call that. DE, which is the external secant segment. And note here, one of the things is they have to meet at a point. Yeah, if they just intersect. So if they intersect, then we can multiply these things together. You get the same number.
Is this related to Pythagorean theorem?
Nope, good guess. I don't know. Might
Looks like it. Okay, carry on.
It's more related to our proportionality theorems or something. Cool. So then we can multiply these guys together. And is it 5 times 5.4? No, it's not. It is 5 times the sum of 5 and 5.4. Remember, if I do my cool colors, it's the red section times the purple section equals the green section times the blue section. Bam, it comes out the same. So I'm going to give up on colors here. So that means that 5 times, what's 5.4 plus 5? 5.4 plus 5 is?
10.4.
Yeah, 10.4. Cool. 10.4. That's going to be equal to what times what?
4 times 4x.
times 4 plus x, which is not 4x. 4x is 4 times x.
Oh, right.
Yep, we're adding them.
Yep.
So yeah, we're gonna do a bunch of math with that.
Joy.
That's 52 equals 16 plus 4x.
I knew there was
Cool.
a 4x.
We're doing good. We're algebraic. Okay. Then we're gonna subtract 16, right? What's 52 minus 16? 36. Cool. Good. Equals 4x. And so x equals 9, as they say in the France.
Vraiment?
Yeah, see? X is 9, see? How do you say X in French? X. I thought you were good at French.
I don't know
It's
the
totally
alphabet.
X.
No, remember I missed the first week of French in high school, and ever since then I cannot count.
Next
or do
section.
My alphabet.
Secant tangent product theorem.
don't
Again,
know.
blah, blah, blah. We have a tangent line here that intersects with our secant line. Ba-doop, ba-doop, and basically says that this section times this section is equal to this section squared. Cool. Got it.
How's this not Pythagorean?
Because it's
Sorry.
I mean,
Go on.
circles are triangles, and nobody believes it.
What?
Yeah, that's what Kyle says.
Who's Kyle?
He doesn't believe it.
Kyle.
Okay, so 6 times 4. 6 times 4 equals x squared. Cool. So therefore, x squared equals 20. Oh, I put it right there. Wait, what? How did I mess that up? Oops. Nope. Ah, shoot. I messed it up. Shoot. That's what I get for going quick. Nope, you didn't see that.
Secrets.
We go back to this, and then I go carefully, and I go this thing times this thing is equal to this thing squared. That's better. So this thing times this thing, so 4 times 10 equals x squared, or x equals root 40, or 2 root 10. Sorry. There's a bunch of these. Cool. Now we're on 15.5, angle relationships in circles. This time we got some chords that are crossing each other, and we have to figure out something about the angles here, and we have this pair of vertical angles. So those angles are equal, right? And then we got these arcs that they make. I'll use red again, I guess. We got arc AB, and we got arc CD. And the cool thing is that there's a formula here. You can read it on your own. The intersecting chords angle measure theorem. Measure. That AB and CD, when you average them, you get the angle in the middle. So that's what this thing is, right? It's basically an average. So we can do that. We can say that PR plus SQ over 2 equals 58. Yeah, and we know what SQ is, so I'm going to just erase that. And I'm going to put in a value of SQ is 82. 82. So then wife, we're going to solve for PR.
No.
So what's first step? Times 2. Cool. Times 2.
That's
Yeah,
what I
those
said.
cancel. And you get PR plus 82 equals 116. You're doing good. Okay, now subtract 82 quickly before I write it down.
No.
Quick.
I need a
Equals?
pen.
Nope. What's 100 minus 80?
Minus
20. So we add 20 to
20.
16, and then we subtract or add 2. Add 2, subtract 2. We over subtracted. So we
6.
have to add 2 back.
36.
38.
36.
28.
Oh, dang it, it's 82. I thought it was 80.
Yeah, that's what I was.
Fine, you win this time. Wait,
did
isn't
I,
it
no,
minus?
No, I don't know what you're talking about.
about.
Yes, no, like I can do math in my head.
4.
Yes, I
34.
totally got 34. Nope.
No, I got it first.
Yep, sure you did.
You need to go back to school, son.
Cool, there's another one here. We have a tangent and a secant, and this also works with a chord. This point is right here on the point of tangency. It forms a super cool angle right there.
Ooh.
How is that angle related to arc AB? Well, it's half. We've done kind of this sort of thing before.
Huh.
So for example, if this angle is 61, this arc PN is equal to
What am I doing?
this arc is 61, so therefore this arc is equal to
You said it was half of it?
120. Good job.
No, double. That's double.
Well, the angle is half of the arc. Okay,
Okay.
redeem yourself. What is half of 238? And note here the 238 is PQN. Is that
119?
Yay! You did.
Yay!
Okay.
I am redeemable.
Moving on. Tangent secant exterior angle measure theorem. Looks complicated, confusing. Just ignore the fact that it has a bunch of words and realize that we have a thing. If we have an angle outside the circle, it's going to be one of three things. Either those rays are going to go through the middle of the circle, or they're going to touch the circle, or one is going to touch and it's going to be the outside. If we have a one, they're either going to be secants or tangents. They're not just going to be some random things. Otherwise, we can't do any math with them. So just keep in mind, we can either have two secants, two tangents, or a secant and a tangent. And regardless, however it comes out, the measure of that angle is equal to 1/2 the difference of those arcs. So in the case of AD, right, it's obviously much bigger. So we just subtract the small one from the big one. Same deal here. We have this inside arc, and then we have this big outside arc, which incidentally will add up to 360, right? But when we subtract them and then divide by 1/2, we'll get this angle here. And then same deal with this guy. We take the big one here, subtract this one, divide by 2. So we'll do an example. This guy here. Doesn't really matter if they're secants or tangents, but we have one secant and one tangent. We have 161. We have 67. She's working already. She's like, oh, he's going to ask. So I'm going to ask you, what is 161 minus 67? And you're going to say it is 94. Okay, 94. And then half of 94 is?
45D7.
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 Yay! You got it right. Okay. This thing isn't anything new. It's just like kind of a summary of what's going on. So look through that. Use this as your cheat sheet when you try and memorize this stuff. That's it. That's all I got. Bye.
Good night.